What if I told you there's a car that routinely hit 300,000 miles with only 80 horsepower and bias-ply tires? Not some exotic supercar with NASA-grade materials, not a military vehicle built to survive war zones. We're talking about a humble Japanese sedan that most Americans couldn't even pronounce correctly. In 1966, the Toyota Corona, a car so unremarkable on paper that dealers struggled to get people to test drive it. Yet this unassuming machine would single-handedly destroy Detroit's monopoly on reliability and launch the Japanese automotive invasion of America. Picture this. It's 1966 in Los Angeles, and yellow cab driver Eddie Martinez pulls into the depot after another 14-hour shift. His meter shows 287,232 miles. The dispatcher shakes his head, thinking the odometer must have rolled over twice. But Eddie's Toyota Corona is still on its original engine, original transmission, even the original clutch. Meanwhile, the company's fleet of Checker Marathons and Plymouth Belvederes are getting rebuilt every 80,000 miles. The other drivers think Eddie's pulling some kind of scam. How could this tiny Japanese car with a lawnmower engine outlast American iron built for taxi duty? The 1966 Toyota Corona wasn't trying to be revolutionary. It wasn't trying to be fast, luxurious, or even particularly attractive. But what happened when this modest sedan hit American shores would fundamentally alter the global automotive landscape. This is the story of how Toyota weaponized reliability, turned boring into bulletproof, and proved that sometimes the most devastating innovation isn't about adding more. It's about never, ever breaking down. To understand why the Corona shocked everyone, we need to travel back to 1966 America. This was the height of the muscle car era. Pontiac was dropping 400 cubic-inch V8s into GTOs. Ford and Ferrari were battling at Le Mans. Chevrolet's Corvette was pushing 425 horsepower. American cars were getting bigger, heavier, and more powerful every year. The average family sedan weighed 3,800 pounds and packed a V8 engine. Gas was 32 cents a gallon. Nobody cared about fuel economy. The conventional wisdom was simple. American cars were the best in the world. Sure, they might need a valve job at 40,000 miles. The transmission might give out at 60,000. By 100,000 miles, most cars were ready for the scrapyard. But that was normal. That was expected. Cars were disposable commodities like refrigerators or washing machines. You bought one, drove it until it broke, then bought another. The Big Three had this cycle perfected. Planned obsolescence wasn't a bug. It was a feature. Japanese cars? They were a joke. The few that had trickled into America in the late 1950s were tinny, underpowered, and fell apart faster than American cars. The 1958 Toyopet Crown, Toyota's first attempt at the U.S. market, was such a disaster that Toyota actually withdrew from America entirely. The thing couldn't even maintain highway speeds. It overheated. Climbing the grapevine into Los Angeles, dealers sent them back to Japan. Toyota's engineers went back to the drawing board, completely reimagining what an export car should be. But here's where it gets interesting. While American manufacturers were focused on style and power, Toyota was obsessing over something else entirely, what they called Kaizen, continuous improvement. Every failure was studied, every complaint was analyzed, every returned part was dissected. Toyota wasn't trying to build the fastest car or the prettiest car. They were trying to build a car that would never, ever let you down. The Corona that arrived in America in 1965 as a 1966 model was the result of 9 years of obsessive refinement. It wasn't Toyota's first Corona. That came out in 1957. But this third-generation model, internally designated the RT40, was specifically engineered for export markets. Toyota's engineers had spent years studying American driving conditions. They knew about the long highways, the stop-and-go city traffic, the extreme temperatures from Arizona to Minnesota. They designed the Corona to handle all of it. Under the hood sat a 1.9-liter inline-4 engine. The 3R engine, as Toyota designated it, produced just 80 horsepower at 4,600 RPM and 103 pound-feet of torque at 2,600 RPM. By American standards, these numbers were laughable. A contemporary Chevrolet Impala with the base 283 V8 made 195 horsepower. Even the compact Falcon with its inline-six made 120 horsepower. The Corona's 0-60 time was a leisurely 19 seconds. Top speed? About 87 miles per hour, downhill with a tailwind. But Toyota's engineers weren't chasing horsepower. They were chasing something far more valuable: mechanical sympathy. The 3R engine was understressed to an almost comical degree. The cast-iron block was massively overbuilt, with thick cylinder walls that could handle far more pressure than the mild cam and single carburetor would ever generate. The compression ratio was a modest 8.51, allowing it to run on regular gasoline without pre-ignition. The three-bearing crankshaft was forged steel, balanced to perfection. The connecting rods were shot-peened for strength. Every internal component was designed to operate at maybe 60% of its maximum capacity. The transmission choices were equally conservative: a 3-speed column-shifted manual or a 2-speed Toyoglide automatic. Not 4 speeds like sporty American cars, not even floor-shifted. Just 3 forward gears operated by a column-mounted lever that Toyota called 3 on the tree. The gear ratios were widely spaced but perfectly matched to the engine's narrow power band. First gear was good for 25 km/h, second for 50, and third would take you all the way to that 87 mph maximum. The synchronizers were brass, double-cone units that could handle ham-fisted shifting from tired taxi drivers all day long. The suspension was pure simplicity: independent front suspension with coil springs and wishbones. Solid rear. Axle with leaf springs. Nothing fancy. No sophisticated multi-link setups. No air suspension. Just proven technology executed with fanatical attention to detail. The ball joints were sealed and pre-lubricated for 30,000-mile intervals. The shock absorbers were specifically tuned for American roads, softer than Japanese market versions to handle expansion joints and potholes. Those bias-ply tires everyone mocked? 6 45-13s that looked like they belonged on a wheelbarrow compared to American cars' fat rubber. But they were specifically chosen for longevity over performance. The narrow contact patch reduced rolling resistance. The tall sidewalls absorbed road imperfections. The tread pattern was optimized for wear, not grip. Corona owners routinely got 40,000 miles from a set of tires when American cars were lucky to get 20,000. The body was equally overbuilt. Toyota used thicker steel than necessary, 18-gauge for most panels when 20-gauge would have sufficed. Every seam was welded, then sealed with a rubberized compound to prevent moisture intrusion. The underbody got multiple coats of rust-preventive primer. The paint process involved 7 stages, including a phosphate dip that chemically bonded the primer to the metal. Door hinges were massive forged units that could handle millions of cycles. Window regulators were gear-driven instead of cable-operated. Everything was mechanical, simple, and bulletproof. The interior was Spartan but thoughtfully designed. Vinyl seats that could handle years of sliding in and out. A metal dashboard painted to match the body color. Manual windows. Manual locks. An AM radio if you splurged for the deluxe model. The heater was powerful enough to defrost windows in minutes, but simple enough that it rarely broke. No power accessories to fail. No complex vacuum-operated systems. Just switches, cables, and levers that connected directly to what they controlled. So what made Los Angeles taxi companies take a chance on this underpowered oddball? Economics. A new Corona cost $1,160 in 1966. A Checker Marathon, the purpose-built taxi, cost $3,200. A Plymouth Belvedere sedan was $2,400. The Corona was cheap enough that companies could buy 2 for the price of 1 Checker. If they lasted even half as long, it would be a win. nobody expected what actually happened. Yellow Cab of Los Angeles was the first major fleet to experiment with Coronas. They bought 6 in early 1966, assigning them to their most reliable drivers as a test. The dispatcher, a grizzled veteran named Frank Kowalski, kept meticulous records. Every fuel fill-up, every maintenance item, every complaint. He expected the little Toyotas to fall apart within months. LA taxi duty was brutal, 300 miles a day, 7 days a week, constant idling in traffic, repeated full-throttle merges onto freeways, passengers slamming doors, trunks loaded with luggage. If there was a torture test for automobiles, this was it. 3 months in, Kowalski noticed something odd. The Coronas hadn't needed anything except oil changes, not even brake pads. The Checkers and Plymouths in the fleet had already required various repairs: water pumps, alternators, tune-ups. The Coronas just kept running. 6 months in, still nothing. The drivers were starting to request the Toyotas because they never broke down during shifts, meaning no lost fares. At 50,000 miles, Kowalski expected the Coronas to need major work. That's when American cars typically required valve jobs, ring jobs, or transmission rebuilds. He had the shop do compression tests on the Toyota engines. The results were shocking. Compression was still within 5% of factory specifications. The engines weren't even broken in yet. The transmissions shifted like new. The clutches showed minimal wear. The only parts replaced were filters, fluids, and one set of brake pads. The real shock came at 100,000 miles. In the taxi business, this was considered end of life for a vehicle. The Checkers would have had their engines rebuilt at least once by now. The Plymouths would be on their second transmissions. But the Coronas were still on all original components. The engines didn't burn oil. The transmissions didn't slip. The electrical systems worked perfectly. Even the upholstery was holding up better than the American cars, despite the constant use. Word spread through the taxi industry like wildfire. Other companies started buying Coronas. City Cab, Bell Cab, Independent Taxi. They all wanted these miraculous Japanese cars that never broke. By late 1967, there were over 200 Coronas in taxi service in Los Angeles alone. Mechanics who had been skeptical were becoming believers. These weren't just reliable cars, they were redefining what reliability meant. Let me put the Corona's fuel economy in perspective. In taxi service, with constant stop-and-go driving, air conditioning running, and fully loaded with passengers, the Corona achieved 25 miles per gallon. The Checker Marathon got 11 mpg. The Plymouth got 13 on a good day. At 300 miles per day, that meant a Corona used 12 gallons of fuel, while a Checker burned through 27 gallons. Even at 1960s fuel prices, that added up to massive savings. Over 100,000 miles, fuel costs alone saved taxi companies over $1,500 per vehicle. But here's the kicker. The Coronas kept going, and going, and going. Eddie Martinez's Corona, the one that had shocked everyone at 287,000 miles, it made it to 412,000 miles before Yellow Cab finally retired it. Not because it broke down, but because newer safety regulations required features it didn't have. The engine was still running smoothly. The transmission still shifted perfectly. They sold it to a mechanic who used it as his daily driver for another 3 years. The highest mileage Corona recorded in taxi service belonged to city cab driver James Park. His 1966 Corona accumulated 467,892 miles before a drunk driver totaled it in 1974. When they pulled the engine to check its condition, the mechanics found the cylinder bores still showed the original crosshatch pattern from the factory honing. The main bearings were within specification. The cam lobes showed minimal wear. This engine had outlasted 3 presidential administrations and was still technically serviceable. Toyota's quality control system was unlike anything American manufacturers had seen. Every single Corona engine was run on a dynamometer before installation, not a random sample, every single engine. They were run through heat cycles, load tests, and vibration analysis. Any engine that showed the slightest irregularity was pulled and rebuilt. The rejection rate was less than 0.3%, but that wasn't good enough for Toyota. They wanted zero defects. The assembly process was equally meticulous. Workers had the authority to stop the production line if they spotted a problem. In Detroit, stopping the line was a firing offense. At Toyota's Motomachi plant, it was encouraged. They called it judoka, automation with a human touch. Each worker was responsible for the quality of their work. They signed off on their operations. If a problem was traced back to them, they were involved in finding the solution, not punished for the mistake. The Corona's simplicity was its secret weapon. While American cars were adding power steering, power brakes, power windows, air conditioning, and automatic transmissions as standard equipment, the Corona stuck with manual everything. Fewer parts meant fewer things to break. Manual steering might require more effort in parking lots, but it never leaked fluid or lost assist on the highway. Manual windows never failed with the glass halfway down. The simple heating system never developed vacuum leaks that affected engine running. This philosophy extended to the engine management. The Corona used a single Kaizen carburetor, one barrel, mechanical choke, no emissions equipment beyond a basic PCV valve. American cars were already struggling with primitive emissions controls that hurt performance and reliability. The Corona's engine was so efficient and complete in its combustion that it actually produced fewer emissions than many American cars with twice the displacement, without any add-on equipment. The 1966 Corona's impact on American automotive culture was slow but devastating. At first, Detroit dismissed it. General Motors executives literally laughed when shown a Corona at an auto show. Ford's product planners called it unsuitable for American tastes. Chrysler didn't even consider it competition. They were all wrong, dead wrong. By 1968, Toyota was selling 20,000 Coronas annually in America. By 1970, that number had tripled. But more importantly, every Corona owner became a Toyota evangelist. They told friends about their car that never broke. They showed neighbors their maintenance records, or lack thereof. They bragged about fuel economy when gas prices started rising. The Corona created something American manufacturers had never really dealt with: genuine brand loyalty based on reliability rather than style or patriotism. The taxi industry adoption was particularly damaging to Detroit's reputation. These weren't Japanese car enthusiasts or early adopters. These were hard-nosed businessmen who cared only about the bottom line. When they started choosing Coronas over American cars, it sent a clear message: Detroit had a quality problem. The fact that an 80-horsepower economy car could outlast purpose-built taxis was embarrassing. It was David versus Goliath, and David was winning. American manufacturers tried to respond. They claimed the Corona's reliability was overstated. They pointed out its lack of power, its tiny size, its Spartan interior. They ran ads emphasizing American cars' style and performance. But they missed the point entirely. Corona buyers didn't care about style. They cared about getting to work every day without breaking down. They cared about not having repair bills. They cared about a car that just worked. The technical reasons for the Corona's longevity went beyond just overbuilding. Toyota had perfected something called design for manufacturability. Every component was designed not just to function, but to be assembled correctly every time. Parts could only go together one way. Fasteners were standardized. The entire car used only 5 different bolt sizes. Wiring connectors were color-coded and shaped differently so they couldn't be mixed up. This reduced assembly errors to near zero. The metallurgy was equally advanced. Toyota had developed relationships with steel suppliers that provided consistent, high-quality materials. The cast iron used in the engine blocks had a specific grain structure that promoted even wear. The steel in the body panels had the perfect balance of strength and formability. Even the nuts and bolts were special, coated with a zinc chromate finish that prevented corrosion for decades. Let that sink in for a moment. Toyota was putting the same anti-corrosion treatment on hidden fasteners that American companies didn't even use on visible trim pieces. This attention to detail was incomprehensible to Detroit executives who were focused on quarterly profits and annual model changes. Toyota was building cars to last decades, not just until the warranty expired. The Corona's engine internals were equally over-engineered. The pistons were made from a high-silicon aluminum alloy that expanded at the same rate as the iron cylinder bores, maintaining consistent clearances across all temperature ranges. The piston rings were chrome-plated for wear resistance. The valve stems were chrome-plated too. The timing chain was a double-row design that never stretched. The oil pump was gear-driven, not chain-driven, eliminating another wear point. The cooling system was designed for neglect. The radiator was 30% larger than necessary for the engine's heat output. The water pump impeller was cast iron, not stamped steel that could corrode and break apart. The thermostat was a simple, wax pellet design that rarely failed. The heater core was made from brass, not aluminum, that could corrode from electrolysis. The hoses were reinforced with multiple fabric plies. Corona owners routinely went 100,000 miles on original hoses and belts. Even the Corona's electrical system was bulletproof. The alternator was a simple 35-amp unit that never seemed to fail. The voltage regulator was mechanical, not electronic, with contact points that could be filed clean if they ever corroded. The starter motor was grossly oversized for the small engine, spinning it effortlessly even in cold weather. The battery cables were twice as thick as necessary. The fuse box used ceramic fuses that never corroded. The whole system was so simple and robust that electrical failures were virtually unknown. But wait, there's more. The Corona's differential was filled with 90-weight gear oil so thick it looked like honey. The ring and pinion gears were shot-peened for strength and run in matched sets. The wheel bearings were massive tapered roller units packed with high-temperature grease. The universal joints were sealed and pre-lubricated for 50,000-mile intervals. The drive shaft was dynamically balanced to eliminate vibration. These weren't sexy features that sold cars, but they were why Coronas kept running when everything else broke. The Corona's success in taxi service led to an unexpected side effect, the creation of a Toyota-specific mechanic network. As more taxis adopted Coronas, mechanics had to learn to work on them. But there wasn't much work to do: oil changes, filters, and occasional brake pads. Mechanics who were used to rebuilding American engines every 80,000 miles found themselves with less work. Some resented it, others saw opportunity and became Toyota specialists, eventually opening some of America's first import-focused repair shops. The parts availability was another Corona advantage. Toyota established a parts network that put American manufacturers to shame. Every dealer had to stock a comprehensive inventory of maintenance items. Parts that weren't in stock could be air freighted from Japan within 72 hours. Compare that to American cars where dealers might wait weeks for parts, and you understand another piece of the reliability puzzle. A car that's waiting for parts isn't reliable, no matter how well it's built. By 1970, the Corona had evolved into a slightly larger, more powerful car. But the philosophy remained the same. The first-generation Corona had proven something revolutionary. Japanese manufacturing quality could exceed American standards, not match them, exceed them. The idea that a car could run for 300,000 miles without major repairs was literally foreign to American consumers. The Corona made it reality. The million Coronas built between 1957 and 1970 weren't just cars. They were ambassadors for a new way of thinking about automobiles. They taught Americans that Cars didn't have to break down. That 100,000 miles wasn't a death sentence. That fuel economy mattered. That size wasn't everything. That reliability was the ultimate performance metric. Think about that for a second. 1 million cars, each potentially lasting 300,000 miles or more. That's 300 billion miles of motoring. The circumference of Earth is about 25,000 miles. Those Coronas could theoretically circle the globe 12 million times. That's the kind of durability we're talking about. Not theoretical durability in perfect conditions, but real-world durability in the hands of taxi drivers, families, and commuters. The Corona's legacy extends far beyond its own sales success. It established the template that Toyota would follow for decades: conservative engineering, meticulous quality control, and absolute reliability above all else. The Corolla that followed in 1968 applied the same philosophy to an even smaller, more affordable package. The Camry that arrived in the 1980s was essentially a larger Corona. Even today's Toyota trucks and SUVs follow the Corona playbook: overbuilt, understressed, and virtually indestructible. The boring but bulletproof reputation that Toyota carries to this day started with the Corona. Car enthusiasts might mock Toyota's bland styling and conservative engineering, but millions of owners know the truth. Boring is beautiful when you're not standing on the side of the highway with a dead car. The Corona taught the world that reliability isn't boring. It's freedom. Freedom from worry, freedom from repair bills, freedom from being stranded. The Corona also proved that Japanese quality control wasn't a fluke or limited to electronics and cameras. It was a fundamental difference in manufacturing philosophy. While American companies focused on fixing problems after they occurred, Toyota focused on preventing problems from occurring in the first place. While Detroit built cars to wear out and be replaced, Toyota built cars to last indefinitely. This wasn't just about better engineering, it was about respecting the customer's investment. The taxi industry's embrace of the Corona sent shockwaves through Detroit that are still felt today. When professional drivers whose livelihoods depended on their vehicles chose an 80-horsepower Japanese sedan over purpose-built American taxis, it was a vote of no confidence that couldn't be ignored. The Big Three were forced to improve quality, extend warranties, and eventually admit that the Japanese had figured out something important. Looking back from today's perspective, the 1966 Corona seems almost impossibly crude. Manual steering, bias-ply tires, no air conditioning in base models, drum brakes all around, no safety features beyond seat belts. But that simplicity was its strength. Every system was mechanical, accessible, and repairable. A shade tree mechanic with basic tools could maintain a Corona indefinitely. Try that with a modern car packed with computers and sensors. The Corona's 25 mpg in taxi service might not sound impressive today, but remember, this was achieved with 1960s technology. No fuel injection, no computer controls, no aerodynamic optimization. Just good basic engineering and an efficient engine that completely burned its fuel. Modern cars achieve better economy through complexity. The Corona achieved it through simplicity and efficiency. The philosophical question the Corona raised still resonates. What's more important, performance or reliability? American manufacturers had always assumed customers wanted power, speed, and style. The Corona proved that many customers wanted something else entirely, a car that would start every morning, run all day, and never let them down. It turned out that reliability was the ultimate performance metric, and the Corona was the undisputed champion. The Corona challenged the entire concept of automotive planned obsolescence. Detroit's business model depended on cars wearing out and being replaced. Annual model changes drove sales. Mechanical failures drove service revenue. The Corona threatened this entire ecosystem by lasting too long. If every car lasted 300,000 miles, the industry would need to completely restructure. Detroit fought this change for decades, but eventually, even American cars became more reliable. The Corona forced this evolution. Today, when we expect cars to last 200,000 miles or more, we forget how revolutionary the Corona was. In 1966, a car lasting 300,000 miles was like a human living to 150, theoretically possible, but practically unheard of. The Corona made it routine. Los Angeles taxi companies were putting 300,000 to 400,000 miles on Coronas and considering that normal. This wasn't just incremental improvement, it was a paradigm shift. The engineering lesson of the Corona is timeless. Perfection isn't about adding more, it's about doing the basics flawlessly. Every bearing surface properly lubricated, every fastener properly torqued, every tolerance properly maintained, every process properly controlled. The Corona didn't innovate with new technologies, it perfected existing ones. That's harder than it sounds and more valuable than most realize. So the next time you see a modern Toyota rolling past with 300,000 miles on the odometer, remember the Corona. Remember that 80-horsepower engine that refused to quit. Remember those bias-ply tires that everyone mocked. Remember the taxi drivers who bet their livelihoods on an unknown Japanese sedan. Remember how one unglamorous car changed everything by doing one thing exceptionally well. It never broke down. The 1966 Toyota Corona proved that David could beat Goliath not through strength or speed but through sheer endurance. It proved that there was a market for cars that prioritized reliability over everything else. It proved that Japanese manufacturing could exceed American standards. Most importantly, it proved that sometimes the most revolutionary act isn't making something faster or more powerful. It's making something that simply refuses to fail. What's the highest mileage car you've ever owned or encountered? Was it a Toyota? I'd bet money it was. Drop a comment below and share your high mileage stories. If you enjoyed this deep dive into the car that changed everything, make sure to subscribe because we're just getting started with stories of legendary engines and the machines that defied expectations. Until next time, keep those engines running, especially if it's a Corona, because if it's still running, it'll probably outlive us all.